So this video is looking at the equations in P2. There aren't that many equations in P2, but there are a couple of things that we need to bear in mind. So the main equations in P2 are linked to power. And power is work done divided by time. Now when we have anything divided by time in physics or in chemistry or in biology even, what that means is we can say that as the word rate. That's what rate means. Rate means divided by time. So the definition of power is the rate of work done, or the rate of energy transferred, because work done is another word or another term for energy transferred. So written in symbols, we write it as P equals E divided by T. The unit of power is the watt, the unit of energy is the joule, and the unit of time is the second. So that's our first equation in P2. The second one is another equation for power, but this equation is linked more specifically to electrical power, and it's I times V. So V in this case is the voltage, obviously measured in volts. I is the current, and the unit of that is A, or amperes. Quite often the question is asked is, why do we use I as the symbol for current? C was taken. C is capacitance, it's something totally different. And I used to stand for electrical intensity, which is why we use it now as current. And then power is still measured in watts. So those are actually our only two equations in P2. The topic that they're linked to is P2D, but they can also include other equations from other topics in P2. Specifically, the one they're most likely to use, which is why I'm going to mention it, is the equation for efficiency, which is useful energy or output energy divided by total energy or input times 100. So efficiency is another equation where they are likely to use in P2, but that is it for P2.